Um, in the meanwhile that you upload your presentation, I'm going to introduce the topic of this webinar. So this is the third webinar organized by EGI, so welcome everybody to attend this webinar. During this webinar, Andrei Tsaregorodtsev will introduce DIRAC. It's a services which provide an efficient access to different computing and storage facility. It provides different functionality, for example, for managing jobs, user workflow, data, and also workflow. The most important characteristic of these services is the possibility to aggregate in a transparent way resources from different infrastructure and using different middleware. These services was originally developed in the to support the requirement of a large high energy physical experiment, but now there are different customization to support the requirement of a different user community. The webinar will be presented by Andrei Tsaregorodtsev, which is the DIRAC project technical coordinator. So welcome, Andrei, and from now you can start to present your talk. Thank you.
Okay, thank you, Giuseppe, for this introduction. So let me start. So today we will speak about DIRAC. Can you hear me?
Yes, Andrei, we can.
Because sometimes I'm losing the sound, and I'm anxious that you are still hearing me. Okay. So I will very briefly describe what DIRAC is about, some origins, where it is coming from, basic systems that can be of interest for the users, and also what are the DIRAC users, who are the DIRAC users, and what are the services that are provided based on the DIRAC software by different infrastructures. Just very quickly, so as Giuseppe mentioned already, the origins of DIRAC are in high energy physics. So actually it is taking start from one of the LEC experiments. So, you know, this is the underground collider at CERN in Switzerland. And as this slide shows, the data acquisition rate of all the four LEC experiments altogether, this is quite an impressive, up to 10 gigabytes per second. So, of course, in a year data taking, for example, it is many petabytes of data. In order to cope with these petabytes of data, the LHC experiments altogether, together with supporting laboratories and funding agencies, have put together a grid infrastructure, which is a worldwide LHC computing grid, WLCG. And now those experiments are collected already altogether more than 100 petabytes of data, which is distributed worldwide. So we have to try to cope with this data. So that's why this infrastructure with many computing centers, more than 150 in many countries. And this infrastructure is huge. And nevertheless, having this infrastructure set up and available for the experiments was not enough. So that's why all the experiments were developing their own tools in order to cope with all the resources which are available from this infrastructure, but also from others, because the collaborations are large and they have access to other types of resources than just grids. So in particular, in the LECB experiment, there was a system called DIRAC that was developed. And so this was developed as a layer on top of the standard middleware that is used to access the grid infrastructure, so that the usual LHCb data production tasks can be facilitated by this system. So we were running the LHCb production system based on DIRAC for quite a while. And of course, we have acquired quite a lot of experience with that. And at some point, we decided that it would be nice to share this experience with other user communities. And about 5-6 years ago, the development team decided to generalize the software such that it is becoming a general purpose one and can suit a wider range of user scientific communities. And also there was a consortium of laboratories and universities that are developing and promoting this DIRAC software was formed. And so now there are 5 members, SUENS, INRES, University of Barcelona, IHEP, and Beijing, China, and CAC in Japan. And so altogether, this consortium now is developing a general purpose solution for building distributed computing systems. So this is what is offered now to the physics scientific communities, not only physics, of course. So if to put it in a nutshell in just one slide, DIRAC is a layer in between the users with their applications and various resources that are available for those users. So it is, in this sense, interconnecting users and resources. It ensures interoperability in between different resources, and it is providing interfaces for the users to access those resources. So altogether, we are speaking about the software that now we call it the interware for these all interconnecting properties. Just to give you a very brief idea how the DIRAC architecture is ensuring this interoperability, it is illustrated by a cartoon which is presented on this slide. So the problem that we have is this one. So there are users that have to execute some payloads on distributed computing resources. And of course, there are computing resources which are available in principle to those users. So they can be of different nature. They can be grids, they can be clouds, they can be just something standalone, volunteer grids, whatever. So how to ensure that the payloads are getting to those resources? This is done with the help of the DIRAC service, in this particular case DIRAC workload management service, which has a central task queue to which the users can submit jobs, pretty much like the users are submitting jobs to batch systems. But there are many users with different applications, with different requirements, different access rights, different priorities, and so on. And all those users are still submitting the jobs in the same task queue of DIRAC. So all those jobs are accumulated in the task queue. And then what's next? Next is the step where a special component, we call it a director, or sometimes it is called a pilot factory, is submitting special kind of jobs to each computing infrastructure. So this submission is done by a dedicated director for each particular infrastructure. All these infrastructures can be very different, but the pilot jobs which are submitted this way to different infrastructures, the pilot jobs are all the same. They are all looking the same. So those different directors and different infrastructures are all getting all the same pilot jobs. So once the pilot jobs are out there, then there is no more difference how those pilot jobs were submitted to those infrastructures. And these make this heterogeneous mixture of different resources a complete homogeneous one, because these are the pilot jobs which will start interacting with the central DIRAC services. And so they will present the descriptions of their resources to the matcher service of DIRAC. The matcher service will find a user payload which requirements are matching the capacity of the resource presented by the pilot job. So that's why it is a matcher service. So the matching is happening here. And all the pilots are getting their payloads. They are executing the payloads on the local computing resources, and the outputs are uploaded back to the central service where they can be picked up by the users. So this is the basic idea about how the DIRAC architecture is providing access to heterogeneous resources in such a way that for the users this looks to be a very homogeneous, essentially a single large batch system from the user perspective. On the other hand, what is very important is that all the user payloads from different groups of the community or from different communities, they are accumulated in a single task queue from where they will be picked up by the real resource. And this is allowing to apply efficiently and precisely the policies of the communities, the user priorities, and things like that. So for the large communities with diversified payloads, this is an extremely important feature, because without a central point where this can be applied to everybody, this is very difficult to apply in distributed environment. Okay, so this is a very brief description of the workload management system, essentially just to give you an idea about how in general it is working, and which computing resources can be connected to such a workload management system. So of course everything started with the computing grids, and of course the grid resources were more or less with the standard middleware like EGI, EMI middleware, or some flavors of similar middleware for the Open Science Grid. Also middleware provided by the NodeGrid project with the ARC middleware. So those middlewares are supported, and in principle, since you saw that it is rather easy to connect yet another infrastructure, just a new pilot director should be developed, other grids can be supported as well. Like, for example, Unicore. Just so far, we did not have Unicore users in our pool of users. So now we are in the era of clouds taking the world. So cloud resources are becoming more and more ubiquitous, and so DIRAC, of course, is supporting cloud for computational payloads in a way pretty much similar to how it is supporting the grids. Essentially, in the clouds, there is a automated procedure based on the status of the task queue if there are waiting user jobs, essentially to instantiate dynamically virtual machines and essentially run inside those virtual machines the same pilot jobs as anywhere on the grid. So again, so the same principle. Once the pilot is there, the system is becoming uniform, and again for the users, they don't really see any difference whether it is a grid or a cloud. And all the currently widely used cloud flavors are supported this way. It can be also standalone clusters. It is sufficient to have SSH access and support the cluster batch systems. So there are many batch systems which are supported, like LSF, BQS, SGE, well, many of them. So this way, for example, how HPC centers, which are not part of any grid infrastructures, can be accessed through DIRAC. And if some particular batch system is not yet supported, again, once the resources and the users accessing these resources will appear, so this will be included into the toolbox of DIRAC. So this is very briefly about the workload management. Now about the data management, because workload doesn't mean anything if you can't deal with the data that you have. So just to be very clear, so the data management problem that DIRAC is solving is the following. So in the DIRAC data management, data is partitioned in files. So it's with the possibly distributed replicas in many different storage elements in the world. So these are files distributed in the storage elements. So these are not data, for example, stored in databases or things like that. And then there are usual data management tasks like upload of the files to the distributed system, registration, replication of the files to make them redundant and more accessible, accessing, downloading files, checking the integrity, and finally removing the data, which is quite a tedious task. So for the users, of course, all these operations should be quite transparent so that they can easily cope with many files. We are not speaking here about just a few. We are speaking about dealing with large numbers of files and tens of thousands, hundreds of thousands. And sometimes there are operations that need to involve many tens of thousands files at a time. For example, replication or removal of large portions of data. So for that, of course, the storage elements that can be distributed, they are not only distributed, but they are also built based on different technologies. And in DIRAC, there is an abstraction layer which is representing all the different storage elements accessed with different protocols. They are all accessed with this abstraction layer with the particular implementations in a similar way for all the storage elements. So for the DIRAC users, those storage elements just seen as logical entities. So the user should not really think about that one storage element is SRM type and the other one is just HTTP and the third one is iron system. So from this point of view, the access to different storage elements is transparent from the underlying technology. On the other hand, we have to keep track of all the physical replicas of our files, so we need a file catalog for that. So in the DIRAC data management system, we are exploiting the model with the central file catalog. So we don't have many different catalogs collaborating with each other. In principle, we can have several catalogs making different functions. So this pattern can be quite useful, for example, for building services which are behaving like catalogs and receiving all the information about data registration, access, and so on. And so, for example, this can allow to build data-driven workflows by using such services. From the user perspective, the user is using yet another interface we call Data Manager, which is hiding, again, all the operations which are directly accessing the storage elements or the catalogs. And for the user, the operations are completely logical. So the file catalog is a central component of the DIRAC data management system. So this component actually defines a single, unique, logical namespace for all the data which is managed by DIRAC. And together with the tools which are accessing the storage elements and the catalog for the users, altogether it represents the data and the whole data management system as a single global file system with the possibility to define access rights to different parts of the data with the rich metadata that can be associated with your files, including user-defined metadata, which is very important. So the DIRAC file catalog is at the same time a metadata catalog, so you can classify your data in a variety of ways. And if you have millions of files, at some point you will have a problem how to find exactly the files that you need for your work now, for your analysis of today. And so with all this metadata defined, it is DIRAC file catalog is providing a quite versatile language which is looking like a Unix find command, where you can choose your data with a variety of criteria. So choose the data from a given subdirectory, which was last accessed, for example, not so long ago, which was produced by whatever version of software, and which have, for example, physical replicas at some particular site, and so on and so forth. So altogether, this can be a very rich selection mechanism that facilitates the task of choosing the necessary data for your analysis. Okay, so far this covers the basic operations with the data, so when you are dealing with particular files. But as I said, in the large user community, especially in a large experiment, very often we need to make operations on many, really many tens of thousands, hundreds of thousands files at the same time, like replication, removal, and so on. In DIRAC, there is quite a complex system which is allowing for these operations. Those operations, once defined, are with the help of the system which we call request management system. Once it is defined, afterwards it is completely asynchronous and happening without intervention of the user until the whole operation involving all those files is accomplished. And for example, for the data replication, this operation can either use direct transfers in between the storage elements, but it can also use third-party services in order to do the actual file transfers. So, for example, the file transfer service, which is developed at CERN, is supported, but if need would be, this service is essentially a plugin that is used in the system, and analogous plugins can be also created for other data moving services, like the services of UDAT project or OneData project, or whatever will be available for the users of this or that community. So the bulk data operations are supported, but also it is very important to have workflows that can cope with such large data sets, data volumes. For that, in DIRAC, there is a system which we call a transformation system, which is essentially each transformation is a recipe how to create jobs and the recipe to which data those jobs should be applied. And the whole system is data-driven, so the fact that a user, that the new data is registered to the system, the input data filter is applied, and if it is the data passes the filter, then the transformation will be applied, so the tasks will be created, and everything is happening automatically once the transformation is defined. And the transformation can be either just processing the data and deriving some results, or the operations can be data replication, for example. And the transformations, of course, can be chained in the output of one transformation can become the input of the new transformation. Just the proper input data filter should be defined. And altogether, it can build, you can build workflows of arbitrary complexity, and some transformations are computational, some transformations are data management, for example. And so altogether, this allows to build very complicated workflows if necessary. These are the base and let's say bulk workflow operations in DIRAC. Very briefly, of course, with which interfaces this can be accessed for the users. Of course, there are quite a number of command line tools, and those we will see in the demonstration today. And but there are also, where is my cursor? There is also a REST interface which is providing maybe not complete functionality of DIRAC, but a good portion of it. So this interface is suitable to use with the application portals, which are becoming quite popular now. So, for example, the WS Pgrade portal was interfaced through the REST interface of DIRAC with the DIRAC workload management system, and it was demonstrated that they can send jobs through DIRAC to whatever resources are managed by DIRAC, as an example. In other interfaces, the DIRAC web portal itself, so we will have a look at that during the demonstration. Just to say that this is the portal, the graphical paradigm of the portal is deliberately following the paradigm of the computer desktop. And in the end, the goal is to provide for the users an abstraction of all those distributed storage and computing resources as a single computer or a single computer cluster for the users with the same rules, same control, same way all those different logical computing and storage elements are accessed with the same global namespace and the desktop-like GUI. So how successful is it? It is up to you, of course, to judge, but this is the goal. So who is using DIRAC? Just very briefly. So of course, LHCb continues to be the largest user of DIRAC. So this is the snapshot of LHCb activity in the last 3 months. So this is the number of jobs simultaneously running as a function of time. So you see that on average, LHCb is running about 50-60,000 jobs simultaneously managed by DIRAC, and so the peaks are going up to 100,000 of concurrent jobs on more than 100 sites. So this gives you the idea of how scalable the DIRAC batch of workload management is. And actually, this is not limited by DIRAC. It's rather limited by the amount of resources available for LHCb. There are quite a number of DIRAC services used by large experiments already. So the Bell experiment in Japan, so ILC, Click collaboration preparing the new International Linear Collider proposal, the BEST-3 experiment in IFAP in China. CTA is an astrophysics experiment, unlike high-energy physics other communities. So the Jean-Faux community at CERN, for example, is using DIRAC to run jobs to verify their releases. And there are also quite a number of other experiments which are looking at DIRAC and evaluating the functionality of DIRAC if it can be suitable for their purposes. another kind of DIRAC installations is that it's not dedicated to a particular experiment, but rather provided by large computing infrastructures as a service for their user communities. So historically, the first national service was provided by the France Grid National Grid Infrastructure of France. So it was hosted in Lyon, and with several universities actually participating in the team which is making the administration of the service. So now it has quite a lot of registered users and supported VOs, so it is in production since 2012. And so this was historically the first DIRAC service of this kind. Not so long ago, it was in spring, I think, 2014, similar service was started for the EGI infrastructure. So as partners, it is operated by the EGI project, hosted in Poland by the Cyfrenet I think it is National Infrastructure, Grid Infrastructure in Poland, in Krakow. And the DIRAC project is providing the software for this installation. So now it is supporting about 10 virtual organizations. In the last year, there were more than 6 million jobs passed through this service. So just to finish, those functionalities are available for the users, either with the dedicated infrastructures or with the services provided by large infrastructures. But DIRAC is also providing a framework, a development framework, in which you can incorporate the pieces which are missing among the standard DIRAC components. So it is very easy to add new components, new services which are necessary for the business logic of your particular application. So right now we already have quite a number of extensions built for different scientific communities within the DIRAC framework. So they are built based on the same software, the same release procedure, the same testing procedure, and so on. So these recipes are quite strict and clear. And a lot of functionality in DIRAC is implemented as plugins. So if, for example, a particular job scheduling strategy is not suiting you, you can provide your own plugin to have logic which is better suiting your applications. And so, for example, there were plugins for managing data sets within the file catalog for the best collaboration. LHCb has a custom module to describe directory trees in the DIRAC file catalog, so which can be with some respect more optimal, and so on. So from this point of view, the point here is that DIRAC is rather easily customizable for the applications of the given community, and this was designed exactly with this idea in mind. Just to finish the bottom line, so all those distributed computing and storage resources and grids and clouds is not anymore something exotic, and many applications need access to these different resources. So the workload management, which is based on the pilot jobs, or we sometimes call them pilot agents, is capable of seamlessly integration of different kind of computing resources, grid, clouds, and others, transparent for the users. So the DIRAC is providing a framework how all these resources and systems can be put together to build a distributed, coherent distributed computing system with a rich set of already existing components, and even more components, custom components, can be easily added. and services which are based on the DIRAC technologies, like the DIRAC for EGI service, can help users to get started with the usage of the distributed computing resources and to see, to reveal its full potential quickly and easily, I hope. So that's it. So this is the presentation part. If anybody have questions on this part so far.
Okay, so thank you, Andrei, for this presentation. First of all, let me give the right to the presenter if they have any questions before to move to the demo. Actually, I would like to ask, because you mentioned you presented different services focusing on the feature to interact with the jobs, with data, etc. I wanted to ask more about the authentication authorization schema. I guess that you are using a digital certificate to access the different infrastructure, grid, cloud, etc. Yeah.
Yes, exactly. All the internal communications of DIRAC and communications with the external services are based on X509 and on so, yes.
And are you supporting, or you plan to support perusal sub-proxy? I mean, the possibility. Sorry, I can't hear you. Can you repeat?
This is already supported.
Is already supported. Okay.
Yes, I think this was the development was done recently, exactly for the training, cloud training resources, which are supposed to be accessed with this certificate. So it is supported.
Okay, because we are evaluated possibility to use this framework, these services, DIRAC, in the EGI long tail of science platform. And one of the requirements to access is the possibility to use robot certificate and the perusal sub-proxy. Since this is implemented or is already supported, probably we can start to discuss about if you are interested in provide a sort of plugin to access the EGI infrastructure, in particular the platform provided by EGI, the long tail of science platform.
Yeah, I think it is perfectly possible. The technical problems were, I think, sorted out. I mean, we use sub proxies, and what can be discussed is how organizationally how this can be done. But this, of course, is offline discussion.
Yeah, of course, this is not part of discussion today. Thank you for this information and your comment. There are questions from the other participants to this webinar. You have the microphone is enabled, so you just need to click on the top bar, the second icon, to switch on your microphone, and you should be able to speak. Do you want to ask something to Andrei about this presentation? Please don't be shy. Okay, probably maybe after the demo,
Yes.
they may have some additional, may have to ask some questions about everything, how it works. So
Yeah.
please go ahead. Okay, thank you.
Okay, for the demo part, I will show you some basic operations that you can do with DIRAC if you just try it out straight away. So, of course, it will not involve operations with zillions of files and jobs, but I hope to give you a feeling how it is quite easy to submit simple payloads and get back the results from DIRAC. So for this demo, we will use just standard EGI service, which is used by the normal regular users of of EGI infrastructure. So we will use grid sites of EGI. If we will be lucky, we will get also some jobs running on the cloud side. So there are not so many resources in the cloud compared to the grid. So this we will see. And we will use some DIRAC storage elements. So we will not use grid storage elements today, but just to make a demo of what you can do with the storage elements. So we will use the web portal of DIRAC and some command line tools. And in principle, the demo materials are based on the tutorial materials that you can find on these URLs. So in principle, if you are interested, you can pick it up and just do it yourself. Okay, so this is a very brief introduction to the demo. So now I stop my presentation and then I will try to share my screen. Okay, do you see my screen?
Yes, we start to see your terminal.
So today we will have to, I will show you two ways of accessing DIRAC. One with the command line tool, so that's why you see my terminal, and the other one is the DIRAC web portal, which is just available in the window next to it. But let's start with the command line because this is probably the most simple way how you can do something already meaningful with your payloads. So as I said, there is quite a number of DIRAC commands. So if you just if you have the DIRAC client installed, I will not show you exactly how to install the DIRAC client. So this is quite detailed in the user guide that you can pick up on the web. I will show you where to pick it up. So if you just type DIRAC and then a tab, so you see that there are quite a number of commands and for various different tasks. So of course we will not go through all of them. So let's put them aside. But some of them are quite useful. So just before going into using those commands, all the commands have -h for the help, and this is a common property of all the commands. So if we just see what is the client that I'm using, so this is the client which is installed, which is using a certain version of DIRAC, and it talks to the EGI DIRAC configuration service. This is the service which will provide all the necessary information for my client to find all the user services and all the components that it will work to. So my client is there, it is fully configured, so we can start to do something interesting. So for today, to start with, I have prepared a very complicated script, which is like that, which is essentially just echoing its input to the standard output. So if I just use it locally, it does this. So not very difficult so far. But let's try to execute the script as a job on the grid. To do that, you do that. You just say submit, and submit in DIRAC jargon, this is dsub command. You just do dsub echo shell hello world. Let's see what will happen. So what is happening is that the job is submitted, and this is the job ID that we are getting back. And now we can see if this job is actually doing something. And you can see that this is exactly this job. So you see this is the job ID that we have just got. and you see that this job is actually running at ECAF in the Netherlands, and so it is already running. And if we say again, okay, so it is already done because it's not showing up. So if we ask to show all the jobs of myself, then you will see that this job is actually done. So now we can try to get the output of this job. This is done by the doutput command and giving the job ID. And once this is done, in the current directory, there is a directory created with the job ID of the job that we just retrieved the output. So if we go to there, we see, we see that there is a standard out of this job, which is given back to us, and no surprise, it contains hello world. Okay, so you see that submission of the job is really simple, and it is running very quickly, and well, this time we happen to execute it in the NICAF in Amsterdam. Okay, so of course this is a very simple example. Let's have a look at a more involved one, but not too much more complicated than this one. So let's see what is the contents of this file, which is a description of a job. So this is essentially the same job, but we will submit it differently. So with the yes, of course we are not in the right direction. So I have prepared this file, which is essentially the same hello world job, but this is a description of a job which can contain many different things. In particular, in this particular job, so it's containing the executable, the arguments, what we want to get as the output, what is the input sandbox of the job. So we are putting our echo shell into the input sandbox of the job, and so this is a complete description of the job, including all the necessary components like executable arguments, input files, output files, complete description. So if we have such a description, then using the same DIRAC command, we are just but with -j switch, we are just submitting this job the same way. And so if you look in this stat, okay, so this is another site in Netherlands, which just matched this job, and so yes, it is already run. So in the meanwhile, while it is running, but maybe it is already done because our job is not really very complicated, so we can get back the results the same way. So let's have a look now how we can see those jobs in the web portal of DIRAC. So the web portal and the command line interface is the two interfaces to the same DIRAC system. So it's not about different systems. So this is the DIRAC web portal. So when you start it, of course, it is in the beginning the portal was void. Yeah. So first of all, in this portal, of course, you can use it once you are registered to DIRAC. For many communities that are supported by the DIRAC for EGI service, the registration of the users is automatic. So if you are registered in the WOMS of your community, of your virtual organization, then chances are that you are already registered in DIRAC. It depends on which community you are. So in particular, today I have chosen to be a user of the ENMR community. So I'm really behaving like a real user today. So I'm not behaving as some training user for just training purposes for a specially prepared setup. No, I'm doing it like a normal user. So, but I can have many different hats. Maybe you will have just one. So I choose to be the VNMR user. Once I have chosen that, in this menu here, you can see that there are quite a number of different applications that you can execute. If you want, of course, you are not familiar with all of them, but if you want to get more information, you can just open the web portal user guide by clicking on the help application or help link here. And this is a link which is pointing to the DIRAC project website. So, of course, what we are interested first is, since we have submitted our first jobs, let's take the application, which is the job monitor. So this is the job monitor, and since I'm a user with, this is Atsarek, this is my username, so let's just pick up the jobs, selecting only the jobs of me, of myself. And so I make this selection, so I can in principle do other selections by site, by the status of the job and so on, but I just have chosen the selection by the username. And I click the submit button, so this selection is applied, and these are the jobs that we have just submitted. The one was submitted by the with the DIRAC command without job description, and the other one was submitted with the job description. So you see that both of the jobs are done, and if you right click on any job, there are quite a lot of different informations about your jobs that are available. This can be quite useful if something is going wrong and you want to see what are the actual details of the job. And in particular, there is yet another way to extract the output of the job. So here in this menu, in the sandbox, you can get the output of your jobs just clicking on this menu item. And so essentially it will be downloaded as a tar file of all the files that you decided to save as a result of your job. So you can just save it and look at it in your local system. Okay. So I think you can certainly have a look at other information provided about the job. So there are a lot of information about in which environment the job was executed, what were the requirements of the job, and so you can have a look at many of these information yourself. Now, the web portal can be used also for the job submission. So in principle, this is also a tool that can be used for the new jobs. So for new submissions, there is a tool in the tools menu which we call Job Launchpad. So if you look at this application, so you see that there are parameters which are used in the job description file that I have just shown you for one of the Hello World jobs. And so these are the basic parameters that you have to provide. So there are some trivial default values. You can always add more parameters. For example, I don't know, the priority of the job, and you can change it value. Or you can just let's submit this job as it is. So it is a very complicated job, but just listing the current directory of the job. So we click on the button, and off it goes. We have got a new job. So now if we refresh the job monitor page, so this is our job, which happened to run in yet another site in Netherlands. Okay, so it is already matched, and if we refresh it once again, it's already running. And so since the job is not very complicated, very soon it is already done. So we can see in the output sandbox, you should be able to see. So we save it, we look, we untar it, and so this is downtown, and I think, so this is actually the listing of the current directory. So the DIRAC jobs are creating some job info file in its current directory. Okay. And with the launch part, there are few predefined sets of parameters. So for example, this set is yet another way of submitting the Hello World job. So we can apply the selected parameters, and those parameters will be copied here. And again, we can submit and get yet another job. Okay. So this launch part, in principle, can be used for submission of of simple jobs, but they can be more complicated uses of this tool. So let's move. Let's return back to the terminal. So now you see how the simple jobs can be submitted, but more complicated jobs need data. Okay, so either they are producing data or they are consuming the data which was produced before. So for data in the user interface, there is a number of commands which are mimicking the Unix commands with which are data related. For example, the command so there are similar commands to the Unix commands with d prepended. Okay, so if you say dpwd, so this will show you your current directory in the logical namespace of the DIRAC file catalog. Okay, so you remember when I was presenting the data management system of DIRAC, I said that we are trying to present all the data which is available, which is managed with DIRAC as a large logical file system. So this logical file system is available with the D style command. So in this case, we are now browsing the logical namespace of the DIRAC workload management system, and you see it is as if you have two shells simultaneously. One is in the DIRAC logical namespace, and the other one is just a local namespace. So in order to get some data on the grid, so we have to upload some files to there. So for the moment, this is my home directory in the logical namespace, but it is RK, so it is already has one file. So actually, I wanted to upload this file. So what I wanted to do exactly that. So this is a file which is in the current directory, local current directory here. So here is this file. So normally I upload it like that. So I upload this file from the local file system to the current directory on the grid. Okay, but of course it is not uploaded because it is already there. If it would be not there, so it would be uploaded. Now we can see that in the logical namespace this file is there, and we can even get more information about this file if we list it with a very long listing, and you see that this file is physical copy of this file is a training user storage element, which is the actual URL to access it is this one. Okay, So we have got our first file on the grid, and we can do something with that. So for example, we can just we can remove it. Okay. So removing the file from the grid, you can imagine this is not exactly a trivial operation, because it should be removed from all the storage elements. All the physical copies of this file should be removed from all the storages, and the file catalog should be um, uh, also cleaned from this file. So you see that yes, so Mandelbrot is no more existing. So let's try to repeat this command to get it back. Okay, and so with this dput command, you can upload your data to the grid. Now let's remove this file locally. Oops, sorry. Oops. Let's remove locally. So locally this file is no more there, and then just to get it back, it is dget. Okay, and you just say dget Mandelbrot, and we have got our file back, so we haven't lost it. Okay, and just yet another operation. As I showed you, this file has a physical replica. So we have re-uploaded it, and the physical replica happened to be now in a different storage element, which is in CipherNet in Poland. Okay, so let's replicate this file to yet another. What was the another one? The training one, training user. You see, the names of the storage elements are logical. You don't really know what is the technology behind the storage element behind the scenes. So just I can tell you that those storage elements are DIRAC storage elements which are accessed with the DIRAC specific DIPS protocol. So if we ask the system to replicate this file to yet another storage element, and if you see now this file is sitting in two different storage elements in the grid. So these are the basic operations that you can do file by file. And as I said, for the massive operations, there is a way for doing this asynchronously, so that you don't have to stay at the screen and wait until you are getting your prompt back. So in particular, for example, there is a command to file to define a replicate and register request. So for example, we can create a file which is containing a list of many thousands of files, and with this command we will just create a request with the request name with these LFNs, and just say that we want all these LFNs to be on this target DC. And the request will be created, and at some point in the future, after all the files are successfully copied, you will be able to see that the request is successful, and so this bulk operation is finally accomplished with retries if the storage element is not available, and so on. So there is a lot of means to recover the failures in this kind of operations. Okay, so these are the basic data commands. So you see that it is not really very complicated to get the data up to the distributed storage and then back. So now let's try to make something more. So as I said, we have just uploaded the Mandelbrot file, and actually this Mandelbrot is an application. So if you just execute this application, Where is my application? So I have lost it. Okay, so let's get it back. So if I just execute it, it's a very simple application which is creating an image. So this is an image that you can have a look, for example. It looks like that. This is a Mandelbrot image. So we will use this application for our examples of how we can submit job and get some data back. So in the predefined set, I have defined the Mandelbrot application. We can apply it. So let me make it more visible. And in this case, the executable will be taken from the grid. So it will be taken from here. So you can specify as input a file in the logical file name in the grid, and then you can just submit it with the executable of this application and some parameters to make a nice image. So we submit it. We have got yet another job. So if we have refreshed, if we refresh it, so it's already running. Oh, it's yet another site but still in the Netherlands. Okay. So this application is running there, and in the meanwhile we can see if it has produced some standard output already. Yes, you can spy on the standard output of the job, and when the job will be done, we will be able to see the image out of this job. Okay. Now this job, so in particular, we can look at the GDL of this job. So the output of this job will be stored as output sandbox. It will not be stored as output data on the grid. It will not be stored in any storage element on the grid. So let's see how we can run the job. Okay, so this job is already done, and we can look at the output files of this job. So we just save it. So let's see. This one. Okay, so we have got a nice image like that. So this happened just in 1 minute, just in front of your eyes. Let's now submit a job with the output data, so that we can produce something that will be stored on the data on the grid. So for that, I have prepared such a job description. So this is here you can see two things. One is this job description will actually produce 10 jobs. This is because this job is so-called parametric job. So we can define a sequence of 10 parameters, and the sequence is just a geometrical sequence of the parameters. So we can each job will be computing a parameter value out of a formula where there is a parameter start, and each new other parameter is just a multiple of the previous value multiplied by the parameter factor. Okay, and but this is just a detail how you can create many jobs in at once. The other interesting thing is that we choose that our output storage element will be the training user. The output path where the output will go will be in the training, and the output data will be the files that are having such a name, where %n is just a sequential number in the sequence of the parameters. So if we just submit this job, which is bulk. So first of all, yes, we have submitted 10 jobs at once rather than just one. So let's see how it looks like in the browser. Okay, so we have submitted these 10 jobs, and 2 of them are already matched. This time it is some Italian site. Okay, fine. And on the other hand, we can see the status of the same jobs with the dstart command in the command line. So you see that we have submitted 10 jobs. They are all defined with the same job group, and some of them are waiting, some of them are already matched, and most of them are already running at some sites. Okay. You remember that we have well, none of them is done yet because this application takes about 1 minute to finish. Okay, so those jobs altogether, they are forming a group because we have given to those jobs a job group name of this name. So we can ask to display only information about this particular group in order not to mix them with the others. Okay, by default, if you do just dstart, it is showing you the jobs which are in the not in the final state, either waiting or matched or running. So that's why you don't see other jobs. If you say dstart -a, you will see all the jobs that we were running today so far, including the done jobs. But we can see all the jobs in all the statuses, but belonging to this group. Okay, so when you are submitting many jobs in advance, the group is quite a useful feature. Okay, so those jobs are running, and in the browser you can see them, so they should be also all running. So this is the refresh. So all of them are running, some of them are already done. So in principle, here in the job monitor, you can see while these jobs are running, you can see other views of the activities which are happening in the system. So for example, you can see for the jobs, for the selected statistics, you can see what are the distribution of current jobs in the system by status or by, let's say, site. So you see we are running in different sites by owner group, but since it is only my jobs, it is a simple group. But it can be also global statistics for all the users. Okay, so in this case, there are other jobs of other users in the system, and of course, the statistics per site is a bit more interesting. Okay, so this is the statistics which is available straight away. So let's see. So some of our jobs are already done, and you remember that we decided to put the output into the training directory. So we see that in our logical namespace, training directory has appeared, and in this training directory, we have already 5 outputs of 5-hour jobs. So let's see. Yes, indeed, 5 jobs are done and 5 jobs are not yet done. Okay, so when they will be all done, you will see in the training directory, you will see all the files that we have produced. And then, of course, since we have produced data, it's not just for the fun of producing data. It means that this data will be analyzed, will be used in some subsequent job. So in this case, what you can do, yet another type of job with input data. So what we can ask in this job is let's do something very simple. So apply your application on all the input data that is provided that you want to analyze. So this input data in our case will be the output of the job that we have just submitted. So when all these 10 files will be available, so we can submit this job. And this job will apply BNLS will make a listing of the current directory of the job, and in this listing we should find all these files, because if the data is specified as input data in the job description for your application, all the input data will be available in the current directory on the grid. So let's see if all our files are already there. 1, 2, 3, 4, 5. Yes, they are all there. Okay, so it means that we can submit the job which is consuming this data. Okay, so we have submitted it. So the job is already running, and just for you to pay attention that this job is still waiting, but the site is already assigned. And this is happening like that because the training user storage element that we have chosen to store our data is defined as local to this particular site. So that's why by default DIRAC is trying to schedule the jobs to the sites which are close to the data that are required by this job. Okay, while this job is waiting, so since we have just a single site that is capable to run this job, so this will take probably a bit longer for this job to get running, because we have less choice where it can be running. Just to give you yet another demonstration, so I use another view of yet another service of DIRAC. So in this particular case, this is the file catalog view of the ASCAD community. Okay, so in this community, so why I just want to show you it here, because this community has quite a lot of data in the DIRAC file catalog in the file catalog service in the DIRAC for EGI service. And so this data not only stored and described in the catalog, but it has also some metadata associated describing its data. So there are these metadata keys which are defined, and we can use some of them. For example, frankly, I don't know exactly what it means. I can just try to select some of them. So the count, let it be CP1. And let's take the antenna. I don't know what is it, but this is for me some criteria that can be used to select some data. Okay, so let's see if we have files which are responding to this criteria. Yes, we have found some files. Yeah, so just for you to pay attention, so there are 100 files per page, and there are 387 pages. So it's about 40,000 files which were found. And you see that it did not take too long time to find all these files. And then what you can do with these files, some normal standard operations, so you can choose some of them and, for example, try to download it locally. Well, we will not do it right now, but in principle, these are one of the operations that you can do. Or you can just try to use this file as input data for your job. So by clicking the corresponding button, you are finding yourself in the job launchpad application, and now you can see that the file that you have just chosen is already put as input data into this form, and there is a predefined set of parameters to execute some ASCAD applications. So let's just apply those parameters, and you see now you have a fully described job to run an ASCART application on the ASCART data that you have just selected according to a certain metadata criteria. So now you can just submit and it will go for the execution. I will just not do that because I'm afraid this is a real ASCART application, so I'm afraid that I can do something nasty with that. But this is rather just a demonstration how easily you can select data and use it as input for the already prepared description of a job with the proper parameters for the executable, for the arguments of the executable, and so on. So if you prepare for your users such a description beforehand, then for your users it will be quite easy to submit jobs. So what is happening to our job? So something is wrong has happened. I think we did not manage to download this data. Well, this is the effect of the demonstration. So do we have all the data available?
Andrei, there is a comment from Carl that probably may be helpful for you.
Yeah, so essentially, I just wanted to finish here. So essentially what I have shown you is how to submit jobs with producing data, how to submit jobs with input data, and you see that you can do it with the web portal, and you can do it with the command line, which of course more flexible than the portal. And the reactivity of the system is quite good, just that something has happened and our last job was rescheduled because it did not manage to find to to run at the first place. But okay, so let's see what happened. But essentially, this is what I wanted to show today. Hello?
Okay, thank you for your demo. Are there any questions to Andrei? Yes, there is a question from Tiziana.
Hi, Andrei. Thanks for the nice demonstration. I have a question concerning the possibilities of sharing files that DIRAC can offer. So I'm specifically thinking about being able to share and access data which hasn't been pre-staged on a storage element in the grid or in the cloud, but which is actually only available locally on a desktop or laptop. Is that possible? So can the local disk be part of the distributed file system?
Oof. The immediate answer, I would say no, because in this case your local disk should be accessed from external, whatever external system, external desktop, external job running on the worker node. So in principle, this needs some access protocol to your local disk. So if, for example, you will install in addition to your disk HTTP server on your laptop and open it to access from outside, then of course yes. But just simply sharing the local disk or I don't quite understand your question, but before actually sharing your data, you have to upload it to some storage that is accessible by some of the supported protocols.
Okay, I think this is answering my question. Thank you. Thank you so much.
And Andrei, another question for you. Before, during the presentation, you mentioned about the possibility to move data across different storage, and also the possibility to be connected with the UDAT and OneData. My question is, this kind of work is in progress. For example, is already available the possibility to interact with the UDAT storage?
We just looked at that, so no, the answer is no. So
Okay.
just that the way how the external storages are interfaced to DIRAC, so this will need quite a minor work. And for example, for UDAT, the storage is, the technology of the storage is largely based on iRODS. Technology which we are supporting already. So this will not be a great deal to use it as an external service either for storing or for moving data in between the storages that are managed by this infrastructure. But from the point of view of the DIRAC users, this will be the same logical storage elements that can be mixed, for example, with the storages which are not managed by EU data. Okay, so from this point of view, this is the model of DIRAC. This is the layer on above different storage and data moving services. So we are just making use of it and making our own abstraction of those resources.
Okay, thank you. Tiziana, do you have another questions?
The second question is related to the handling of permanent identifiers for data. So I'm specifically thinking of a research workflow where after, where actually a job needs to analyze data which is third-party data and which is identified through a handle. Could be EPIC or DOI or other system. So is DIRAC able to manage access to data sets based on the handle information attached to the data set, and also is the catalog, the data catalog of DIRAC able to store information, handle information in it?
Yeah, so the answer to that question is yes. The DIRAC is storing information about the metadata which is associated with the data, like file name, size, access control, things like that, but also the URL, or in broader term, handle how to access the data. So if, for example, this will be the data stored in some storage which is accessible, so the data is accessible by means of this handle, so this handle will be stored in DIRAC. So for the DIRAC user, he will see this data as logical file in the DIRAC file catalog, but when accessing it, the proper protocol will be applied, because we know what is the storage element behind, and the proper handle will be applied to access this data. But in order to do that, of course, these data must be registered in the DIRAC file catalog with all these details, because of course, if we know nothing about this data, we can't access it. So, and this is a quite usual task that there are already communities that having their data stored in some way, for example, registered in LFC or in some other catalog, or just without any registration, just trivial file catalog, just namespace of the physical storage, many different ways. And so in this case, in order to make this data available through DIRAC, so this data should be first registered to DIRAC. And there are tools, for example, to migrate the contents of LFC to DFC. This is a rather common case because LFC is getting less and less support, and still there are quite a lot of actual data in LFC. And for ASCAT, for example, we were just importing the data from the physical storage, essentially. And since they are keeping some metadata together with the data, there was also a part when this metadata was extracted from the actual data in order to be stored in DIRAC as the metadata associated with the ASCAT data. So there are different ways different use cases for that, but after this registration is done, then I think we are quite versatile in accessing data in various different technologies or storages.
Okay, thanks a lot.
Okay, there is another question from Maggie, from Michaels.
Hello, well, it's not Maggie, it's Maggie's
Okay.
colleague sitting next to her. Actually, my name is Oleg. Hi.
Hi.
I was wondering about the characteristics of the execution environment that will be handling the jobs. For example, how many cores can one job get, how much memory, and also the software-wise, what sort of executables are expected? What is the processor architecture? Is the executable, well, the executable, if it is a binary, it probably then has to be compiled according to some architecture. How is it? And is it just the bare all-included executables which are supported, or one can run some other things, for example, Python or R scripts or Java command line program or MATLAB script, things like that? Basically, hardware and the software specifications of the environment, a little bit, shortly, please.
Okay, then very briefly. So first, DIRAC is not providing computing resources, just to make it clear. DIRAC is just a management system which is connecting the applications to the resources which are accessible by the community. So which resources are available to the community, to the users. This is the deal in between the resource providers and the users. So this is not the DIRAC service which is doing that. So you are getting the execution environment, the one which is provided by the resource provider, not by DIRAC. Now, the usual execution environment on the grid, and that's why the grid is great, because it is providing a uniform environment on all the sites, is a particular operating system, which is largely scientific Linux right now. And you can, in principle, specify in your payload description what are the requirements in terms of memory, in terms of numbers of CPU, in terms of CPU time that you need, and so on. And the system, and DIRAC in particular, will find the resource which is corresponding to the requirements of your job. Okay? So that's why it is there is a matching mechanism between the job requirements and the capacity of the resource. Now, the question about how the software, the application, software for the application that you want to run in your job, how it is prepared and delivered to the worker node to run. So there is no a single answer to that. There are a variety of ways how this can be done. If you know that you can run only on a given platform, then you can provide precompiled binary executable in the input sandbox of your job, and then it will be delivered by the sandbox mechanism. Or you can use some global distributed file system like CVMFS. Maybe you have heard about that. This is a very usual mechanism, for example, to distribute the software for the high energy physics applications, but not only for that. This is essentially a large distributed file system. So you can put your software in this file system, and this software will be available on the worker nodes for the sites which are supporting this file system. In DIRAC, for example, for your community, you can define a script which will be executed before your job, well, your application will actually start. And this script, you will put into there everything you need to prepare the software for your application. For example, you can download something, you can try to compile locally, whatever you have to put. So there are a variety of ways how to cope with that. All the applications are different. That's why there is not a simple answer to that.
Okay, thank you. That answers my question.
Okay, fine. Are there any other questions to Andrei? Yes, Baptiste.
Hello, Andrei. Thanks for your presentation. How can we interact with files from a job? Is it possible to use dput and dget and frame and like these commands from a job, or should we have to directly use the appropriate related commands?
Okay, so everything which is what you saw in the command line, all those commands are available inside the jobs, just by definition. Okay, so if your application is a script that is invoking some binaries or whatever, so in this script you can use dput dget commands. Yes.
Okay, thanks. Also, I have another question.
Yes.
Regarding a pilot job.
Yeah.
Are they launched only by jobs and shut down after the job is over? Or are they long-running processes that would reserve a worker node or VM or things like this?
Yeah, this is a good question. So again, this depends a bit. So actually, you can see pilot jobs as a resource reservation. You are right, and for the time the resource is reserved, this resource is under the control of DIRAC. So it belongs to DIRAC. And from this point of view, it can pick up user jobs, execute it, but if the resource is not yet exhausted, it's a shame to give it back. So it will try to make full use of this resource and execute more user jobs if the time is available, and so on. So in the grid, for example, typically there is the pilot is running in a queue with a certain CPU limit, and it knows its limit. It knows at any moment how much time is still left in the slot, and if next time it will present the capacity of the slot to the matcher of the central task queue, it will present the CPU time that is left in the slot. So if there is a short job to fit into the CPU time, with the requirement to fit into this CPU time which is left, it will be picked up. It is even more interesting with the clouds, because in the clouds there is formally no limit for how long you can reserve the virtual machine. So those limits are depending on many different things, but there is no a single standard way to say that, okay, so this virtual machine for no longer than so much. So in principle, in the virtual machines, the pilots can use until they are signaled essentially by the site that please give me the resource back, things like that. So anyway, so pilot will try to make the most use of most of the resource that it managed to grab.
Okay, thanks.
And by the way, you just saw it today. You saw that the jobs are starting almost immediately. Okay, why? It's because the pilots are already there. Actually, those pilots are maybe not submitted for our jobs. They were submitted for the jobs of other jobs of the ENMR community. So from this point of view, if you want, I was cheating a bit, because I was using my identity in this group because I know that there is some activity for this group in the grid, and I know that there are pilots out there, okay, already running for other jobs of other users of this community. So that's why the pilots are already there. They have reserved the resources. That's why my jobs were picked up very quickly. So if I would be starting from complete scratch without any pilots out there, so it would take some time to start the first pilots. But once the pilots are started, the jobs are starting to flow quite quickly. And just to take the occasion of this question, so just to mention that DIRAC is good for managing large numbers of jobs. So if you are submitting just 1, 2, 3 in a while, so probably you will not see much advantages of the scalability properties of the system. But if you have to run 10,000, then you will see how the efficiency is higher. So that's why all those high energy physics experiments were actually implementing a layer on top of the middleware. So that's why this middleware is really for high intensity, high data intensive, high computation intensive applications. Okay.
Okay, thanks. And another one is regarding usage of certificates. So you said it's possible to use both robot certificate and user-specific certificates.
Yes.
Okay, great.
So so what is the question exactly? The time span of for how long they are valid or what?
No, it was just to be sure that it was possible.
Yeah, so the robot certificates are fully supported. In fact, this is not a technical problem usually in DIRAC in particular, because robot certificates appeared not so long ago, and in principle, it was not immediately clear that security-wise they are acceptable by all the sites. If you want, the pilot jobs are robot certificates, jobs which are running with the robot certificates, if you want. So this was the first implementation of a robot paradigm. And it took us quite a while to convince sites that this is not really a security hole. Okay, because the sites seeing different identity compared to the identity of the real owner of the payload. So in this case, robot certificates has the same problem, but now it's no more the problem. So that's why it is technically fully supported, and this is not a technical problem, but rather policy, security, whatever.
Okay, thanks.
Okay, I think we can close the webinar now because most already left, probably because they have already busy with other meeting. We thank Andrei once again for the presentation and the demo. It was very interesting for all of us, and we hope to work together to better support other use cases. Okay, thank you everybody, and have a good afternoon. Bye.
Okay, thank you. Bye.
Ciao.
Thank you, bye.
Bye bye.